Okay, this is a simple video on how to create a flow volume from an NX solid part that has an internal chamber. So if you're doing a flow analysis or a purge cavity or maybe a fluid flow and you want to do a model for CFD. So I'm going to go ahead and open this valve part, and this is actually taken from the tutorials that come with NX, the valve part here anyway. And you can see it's an interesting coordinate system. I'm not sure what the intent was with that, but we've got this real basic valve body, and you can kind of look inside here and see that we've got a flow chamber through there, and there you can see the valve area inside. So what we're going to do is execute a couple of commands at one time. So what's a bit tricky about this is that you need to stay in the command and then execute some of the other features. One of the nice things about NX is that some of the various function menus and things are available to you while you're in the middle of another command. So you don't have to leave a command to actuate another command or activate. So we're going to come in and we're going to use synchronous modeling for this, which is a great tool. You've got delete face. And so what we're going to do is, if you delete a face of a solid, it has a tendency to want to restitch itself and heal itself over. So we're going to switch this to face. And what you can see is we've got this set for face over here. And this option you'll want to play with. It's got a lot of different opportunity to do a single face, tangent faces, which basically means anything that's not across a sharp vertex. Adjacent faces will take the first face across the adjacent, even a sharp vertex. Feature faces, region faces, connected blend faces like fillets, all blend faces, boss or pocket faces. We use this one a lot because boss or pocket faces definitely has a lot of implications when there's a lot of internal nooks and crannies. And rib faces and slot faces. For this one I'm going to pick the pocket faces, and I'm going to kind of look in the hole here, and I'm going to pick anything that's on the inside there, and you can see what it did was, and we need to expand this. I'm going to turn off the preview, and now it'll open back up. But because the preview is on, it's showing you the cap option, which is to make a new face or plane over the opening. So anything that's an opening to the volume, it's going to automatically try to cap it off. You can select and remove. We'll turn the preview off for now. And if you look, because of the fact that we used boss or pocket faces, it did a pretty thorough job sort of running the inside of the solid there and selecting probably everything inside there. It's hard to tell sometimes whether you've got exactly everything. So now the tricky part is you need to come up and do an edit and then a selection. And you'll notice over here that edit, polygon, select all, deselect all. Well, we don't have the option all but selected. And so what we're going to have to do is come to the command finder and type in all but selected. Well, you have to wait while it builds the command map, but if you're not familiar with Command Finder, you want to use this tool. If you put in something close or the name of a command you're looking for, it's going to help you find it if it's available in a particular application that you're in at the time. Since NX has a lot of different modules and applications, some commands are not available in all applications. And when it does find it, you'll note that it will show you where it is in the menus, what tool buttons, which menus it's under. Now in this particular case it wasn't on our menu, and it should flag us to that. So here's the all but selected, and you can see currently hidden. It's not on the selection toolbar and it's not on the menu. For instance, deselect all, you can see that over there it highlights it as I hover over it. And there you can see there's an example of when you pull down something that's in the menus, it folds out the menus to show you where it is. So one of our options, if we pull this arrow down, is add to the menu bar, or add to the toolbar, or add to the menu. So we're going to go ahead and add it to the menu. Now when we hover over, it folds out, and we can see that it is right below the select all and deselect all. So we're going to close out of here. We've still got this command active this whole time. My selection is still there. We're still in the middle of this command. We're able to do this other stuff while we're in there. So now we're going to say edit, selection, all but selected. And what that does is just flip-flop to a complete reversal of our selection set. So instead of all the internal wetted surfaces, and that's a term I should have used earlier, you want to select your wetted surfaces for the flow volume, anything that the fluid is going to touch in the volume. And now we've inverted it, and we've selected everything that is not a wetted surface. And what you'll see if we turn on the preview now is it will delete all of those surfaces and then automatically close the volume of the internal cavity. So what it's done is it's inverted and turned the internal air cavity into a solid cavity. And we're going to go ahead and say OK. So now what we have is a nice solid body representation, and we can see that if we come up here and select solid body, that this is one solid body now of the internal flow volume. So this is the actual airspace going through the valve, and this could be used to create a fluid mesh. This is now a part, and you can save it as the valve. In our case, we'll go ahead and do a save as, and we're going to say it's the valve part flow volume. Alright, so now we have the flow volume. And this is where we could then go into, for instance, advanced simulation. And we might want to build a new finite element model. And let's make sure that we're so now we'll go ahead, we'll let it create the idealized part. We can turn all these on, which I like to have all these on anyway, and usually set them in my customer defaults to be on. This just gives you a chance to include different geometry. If you've got points in your part and other things that aren't solid geometry, some form of construction geometry, you can turn those on. We don't have any in this particular one. Alright, so this is now our polygon geometry. We can see, for instance, if we decide to do a 3D tetrahedral mesh, we can do an estimate. A lot of times I like to divide my estimate in half or something like that, and it is nice to remember again that the dialog box text fields are typically free form, so you can go ahead and put a math type equation in here. I want 5.76 divided by 2, and I'll do an apply, and it'll generate that mesh. Alright, there we go. So we've got a nice 3D TET flow mesh. We can put boundary conditions on here, establish a flow. We can take this into NX flow and NX thermal and do some stuff with it. And treat it like any other solid part at this point. If we wanted to use more synchronous technology on it, we could. And that is how to make a quick, fast flow volume from a solid part. And I'm going to do another short video where I show how to do this with a more complicated part that starts out as a multi-part, multi-component assembly.